Traditional refrigeration begins with a compressor, moving refrigerant through a network of coils to transfer heat away from the cooled space. The compressor and fan consume energy while continuously circulating refrigerant, creating the familiar machinery found inside conventional cooling systems. As the system operates, heat is removed from the chamber and moisture condenses across the increasingly cold surface. But researchers are exploring another approach, replacing bulky mechanical hardware with compact materials engineered to manage heat differently. Inside this laboratory, engineers begin with carefully controlled materials that will eventually become the foundation of the compact cooling module. Thin substrate rolls, functional films, metallic layers and specialized coatings are prepared before the manufacturing process can begin. Each sample is handled carefully because even small variations in thickness or surface condition can affect the finished cooling structure. Under magnification, technicians examine the surface closely, searching for defects before the material enters the production sequence. A uniform surface gives the production line a reliable starting point, allowing the next stages to build precise functional layers. Once the material passes inspection, it leaves the laboratory and moves toward the automated production floor where transformation begins. The approved material now reaches the production floor, where automated equipment prepares it for precise industrial processing. Before entering production, each batch is identified and recorded, so its material specifications remain traceable throughout the factory. Motorized rollers feed the material into the line, while controlled tension keeps the delicate sheet perfectly stable. Laser sensors measure the moving sheet continuously, checking its dimensions and surface condition before further treatment. When an irregular section is detected, the automated system separates it, without interrupting the approved material moving through the line. The approved sheet enters a controlled cleaning chamber, where precision jets prepare its surface for the next manufacturing stage. Fine liquid jets wash both sides of the sheet, removing particles that could interfere with the precision coating applied later. Powerful air streams remove the remaining moisture, leaving the surface clean, dry and ready for controlled coating. The clean surface now approaches the coating station, where a carefully controlled layer will become part of the cooling structure. The precision roller spreads an extremely thin functional layer across the sheet, creating the first engineered surface of the cooling module. A precision sensor checks the fresh coating as it moves, confirming that the functional layer remains consistent across the entire surface. Controlled airflow stabilizes the newly coated surface, preparing it for the next stage without disturbing its delicate engineered layer. A second engineered layer is introduced from above, traveling in perfect synchronization with the coated sheet beneath it. Precision rollers bring the layers together under controlled pressure, creating a unified structure with almost no visible misalignment. Optical sensors track the edges continuously, while automated guides make microscopic corrections to maintain exact alignment. The finished multi-layer sheet exits the laminator and travels toward the forming station, where it will be divided into individual cooling modules. The continuous sheet reaches the forming station, where automated tooling prepares each section for its final compact module shape. Controlled pressure gives each section its engineered geometry, repeating the same precise shape along the moving production sheet. Once formed, the individual panels are separated and transferred automatically, keeping every component moving at the same production rhythm. The formed panels now enter precision cutting, where each component is positioned and measured before its final edges are trimmed. The cutting head now removes the excess material, creating the exact perimeter required for each compact cooling panel. A controlled finishing operation smooths the edges, removing tiny irregularities before the panels move toward electronic assembly. Small control components are prepared beside each panel, ready to connect the cooling element with its electronic control system. The control board is positioned with precision, aligning its electrical contacts exactly with the connection points on the cooling module. Connections are secured while a controlled thermal interface helps transfer heat efficiently between the cooling element and its supporting hardware. After automated assembly, a technician checks the critical connections by hand, confirming that every component sits exactly where it should. A small manual adjustment brings the assembly into final alignment, completing the human precision stage before testing begins. The completed module enters a controlled test chamber where sensors will measure how effectively it transfers heat during operation. As the module activates, thermal imaging reveals a growing temperature difference between its cooling side and heat rejection side. The system continues operating as sensors record its performance, giving engineers the measurements needed before the finished technology can move toward deployment. After completing the thermal test, the module leaves the chamber and returns to inspection for a final examination of its physical condition. Automated cameras examine the finished module from every direction, checking its surfaces, edges and assembled components for visible defects. A precision probe checks critical dimensions, confirming that the completed module remains within its required manufacturing tolerances. The module is then subjected to controlled vibration, testing whether its assembled structure can remain stable during repeated operating conditions. Electrical testing verifies the module's operating response, recording key measurements before the unit can receive final approval. The recorded results are reviewed against the required limits, confirming whether the completed unit is ready for final finishing. Approved modules move into final finishing, where their surfaces are cleaned and polished before identification and packaging. A precision marking system adds the identification code, permanently linking each finished module to its production record. Each approved module is protected inside a fitted package, keeping the precision components secure during storage and transportation. With testing complete and packaging sealed, the compact cooling technology is ready to leave the factory and enter the real world. From the packaging line, completed modules enter organized storage, where automated vehicles prepare each shipment for distribution. Selected shipments are moved to the loading dock, where finished cooling systems begin their journey beyond the factory. The shipment leaves the facility, carrying a technology designed to make compact cooling possible in spaces where conventional systems are difficult to use. Its compact architecture presents a different approach to cooling, challenging the size and mechanical complexity of traditional refrigeration systems. In the demonstration chamber, the compact system produces visible cooling while occupying only a fraction of the space associated with conventional refrigeration hardware. From raw material to finished technology, every stage brings this compact cooling concept closer to a future where refrigeration could take an entirely different form.